All right, so question 1, very straightforward, composite shape. We've got a rectangle and a triangle, so the area of that composite shape is equal to my rectangle, which would be 8 times 6, which is 48. Subtract my triangle, which is a half times the base, which is 8, times the height, which is 2. 8 times 2. Half of 16 is 8. 48 minus 8 is 40. Is that right? Yes. The total surface area. Make sure that now your formula sheet, ladies and gentlemen, your formula sheet looks like that. It is not going to give you the formula, but it is going to say that for a cylinder, that the surface area is 2 times the area of the base, in other words, 2 circles, 2 pi r squared, and then the circumference times the height, and the circumference is either 2 pi r or pi times d. So 2 pi r h would be that part, and that other part is 2 pi r squared. So you need to think through it. I don't want to give you those formulas. But by the way, you have your bound reference, so you can put in formulas in your bound reference anyway, if you are struggling with that sort of hint there. But anyway, so the total surface area is 2 pi r squared plus 2 pi r h, and the radius is 8. So no, it's 4. So it's 2 pi times 4 squared plus 2 pi times 4 times 20 times 20. Now I'm doing this all in my head. You guys have a calculator, so you can do all of that in a calculator. 4 squared is 16 times 2 is 32 pi, and then that's 160 pi. So that should be 192 pi, which gives you an answer of 603. Voila. Of course, you use a calculator. Volume is area times height. Now remember that when we're finding the volume of a shape, we need the consistent cross-sectional area. The only way I can cut this into nice even slices is if I cut it that way. Therefore, that must be my height. Actually, that's a really bad drawing because that's not parallel, is it? That is my height. So the area is the triangle, which is a half times 12 times 5. That is my area, and my height is 20. Now a half of 12 is 6. 6 times 5 is 30. 30 times that is 600. Is that the answer? 600. Yeah. No, I make plenty. All right. Question 4. We're looking at the total surface area. Now be careful, because we've got two, like a spinning top, but we don't care about the 2 circles. So, first of all, the total surface area of a cone is pi r squared plus, isn't it pi rs? Now, we don't care about the pi r squareds, so it's actually pi rs, and then there's 2 of them. Now, what is the slant height? They've told us what it is. So it's pi times 5 times the slant height, which is 13. So that's for one of them. That is 65 pi for one half. So there's 2 of those. So the answer must be 130 pi. Is that right? Yeah. So just remember that when you go to your formula sheet, and your formula sheet says that the surface area is the area of the base, in other words, the circle. Well, hey, you've got to be careful, because over here we don't care about the area of the circle, because that's not part of the surface. So just be careful when you're doing the measurement questions. We're going to have questions where you're not just plugging numbers into formulas, because a monkey can plug numbers into formulas. We want you to be able to think. So this one. Now, I guess this in the exam, this was done, or students struggled with sort of the concept of it. You think of this as like a block of cheese with a hole cut out. Now, that block of cheese, when you cut out the hole, still has a surface on the inside. So in other words, the total surface area of this block is, we've got the 6 rectangles. So let's work out what they are. We've got 2 rectangles which are 12 by 10. And then we've got 2 rectangles which are 10 by 6. And then we've got 2 rectangles which are 12 by 6.
So is the top rectangle sealed or?
No, so we'll get into that in a second. Yeah. So what we do is we'll work out the full rectangles first. So what we're doing is we're working out those, and now that's 120. So that's going to be 240 plus 120 plus 72, 144, which is going to be equal to 360, 504. Now, so that's for the entire rectangular surface without the circles. But then what we have to do is we need to subtract 2 circles. Okay, so we need to subtract pi r squared, which is pi times 3 squared. And there's 2 of them. Now that's going to be equal to 18 pi. Now, what a lot of people did then is they go, oh, the only one with 18 pi is b, so it must be b if I'm subtracting away. But remember that we need to add a curved surface, the curved surface. Now, the curved surface is 2 pi rh. Now, 2 pi rh is 2 pi times 3 times the height, which is 6, which is 18. That's 36 pi. So if we're adding 36 pi and we're subtracting 18 pi, then we actually, the net result is we are adding 18 pi. So hence the answer is C. Does that make sense? Did many of us get that answer? Yeah? So as long as you interpreted it or visualised it the right way, that those 2 circles have been removed, but there's still the inside curved surface, then you would be okay. Yeah. All right, I'm going to resume. Now, it says here, given that this is equal to this, the discriminant. Now, the discriminant is, and you guys need to know this, it actually comes from the quadratic equation. So, and by the way, the quadratic equation's on your formula sheet, inside the square root. So you don't need to write that down, or you don't have to have that b squared minus 4ac committed to memory, because your formula sheet looks exactly like this. And look, that is the discriminant inside there, b squared minus 4ac. You do get a bound reference for this one, yes you do. So you can write as much as you like. You can put work examples and things like that in there. And how to use your CAS calculator is something I would remind you to do. If for example, like the next question here, axis symmetry, you can just do it all on your CAS. I'm going to show you how to do that. So b squared minus 4ac. Now, of course, you can go ahead and put that in your calculator if you like. But I'm going to, now b is minus 3, so minus 3 squared is going to be, well, we'll write that, minus 3 squared, minus 4 in brackets a times c. Negative 3 times negative 2 is positive 6. So therefore I've got, now to be careful, negative 3 squared is 9, minus 24, so the answer should be minus 15. Would there be any solutions to that quadratic equation? No, there wouldn't, because the discriminant's less than 0. Can't get the square root of a negative number unless you do specialist maths. That's true, all right? It's coming, 2 years. All right, for some of you. The equation of the axis of symmetry. Now, remember that axis of symmetry is the x-coordinate of the turning point. And we can get the turning point by completing the square in your CAS calculator. A lot of you were trying to complete the square by hand and doing all sorts of crazy things, sketching the graph. You're probably just wasting your time. 4x squared plus 2x minus 3. So, if we go to our CAS calculator, and of course your calculator looks a bit different because my version of the software is a little bit old, but you should memorise the complete the square function. You can either type complete square, or you can go to menu, algebra, complete square. You can press menu 3, 5. That's a nice quick way of doing it. Menu 3, 5. Complete square. And then you put in your function, which is, I should have remembered it, 4x squared plus 2x minus 3. Now, you don't need to put in comma x plus 2x minus 3. It should just, oh, you do in this one. I'm not sure, maybe your calculator does? It doesn't. Now, so be careful. You need to put comma x. And have a look. That is now in turning point form. You have a, which is 4, outside of x minus h, all squared. In other words, we've moved this to the left 1/4. So therefore, the x-coordinate of the turning point is negative 1/4, which means the axis of symmetry is x equals negative 1/4. Marcus, you have... All right. Now, so the answer, therefore, is x equals negative 1/4. Now, let's have a look at this. And I can tell you now that you've done your transformations task. So your transformation task, there are going to be some things which are examinable in there. Whether that be reflections and translations, dilations and things, we will ask you to do to answer some questions. But remember, you've got your CAS calculator. One of two things. You could first of all, now we know that the graph of y equals x squared goes through the origin. Okay, you could, if you wanted to, if you were a bit confused with this, you could sketch the graph of y equals x squared. Now, let me just have a look at that function. Okay, so we've got the graph of y equals x squared. So if we go to our calculator, we could put in x squared and whooshka. There we go. We've got x squared. Then we press the tab button. And we could sketch that graph. Now with the next one, on the same thing, and we could see how it's either wider, narrower, where it's moved to. So what we can do is we can press Control Divide, which brings up our fractions tool, and I can press -1, and then we've got 4 down the bottom from memory. And then what was inside the brackets? X plus 1 squared. 1 squared, and then we've got, oopsie, plus 2, wasn't it? Yes? Now, when I do that, you can see there that the key point, this turning point, it is moved to the left 1, and it's moved up 2. And does it look wider or narrower than x squared? It's wider. So despite the fact that you might not be completely nailing the concepts of translations and dilations and reflections, you could sketch both in your CAS, and then that would be a way to do it. Okay? Otherwise, what I'm going to say to you is that the negative part, that is a reflection in the x-axis. It's the x-axis. It's reflected. So y equals x squared would become, well, that's supposed to be the same width, but it's really bad. Negative, that's what the negative sign does. The quarter, because that is less than 1, it makes it wider. If it was like, if this value was 4 and not 1/4, it would make it narrow, wouldn't it? Okay, and then of course we move it to the left 1 and up 2. So the only one which does that, well, we're making it wider, x-axis, trend 1 unit to the left and 2 units up, is the answer C. I think it is C. It is. That is amazing. All right. What about if we had the graph of x squared and it's translated 3 units up? Well, I guess you could sketch it. That's going to be x squared plus 3, but it's basically going to look like this. And that point there is going to be 0, 3. Which one of these is true? Does it have a maximum turning point? No. Does it have 0 x-intercepts? Yes. Yes, it does. It's always nice when in the first couple that turns out to be true, because then you don't have to bother. Okay. In turning point form, the quadratic equation can be written as, well, hey, this is another completing the square. 2x squared plus 4x minus 1. We can go to our, what did I say was the shortcut for complete the square? Menu 3, 5. And we can put in that 2x squared plus 4x minus 1. 2x squared plus 4x minus 1, comma, x, whooshka. 2 outside of x plus 1 all squared minus 3. Answer's B, wasn't it? Yeah. All right. The next one was a pretty straightforward one, but remember that when we're multiplying those through, we need to cancel out that negative sign. 30a squared minus 35ab. So the answer is D. Not going to dwell on that one too much. Solutions to the equation. You shouldn't be doing this by hand. You should be doing this using your CAS. X squared minus 3x equals 5. Like complete the square. Instead of menu 3, 5, it's menu 3, 1 for solve. Menu 3, 1. Solve. And what are we solving? We're solving x squared minus 3x is equal to 5. So we do it. X squared minus 3x is equal to 5. And then what we've got to do is, the calculator's silly. We need to do comma x. Because we need to tell the calculator we're trying to find x. And look at that. It's given us the solutions. Now just be careful. Because the calculator can give you some funny sort of answers. But if this negative carries across, that's going to be positive 3. Negative root 29 over 2. It might not be the answer like in the same format, so you need to just at least think it through. So therefore the answer is 3 minus root 29 on 2 and 3 plus 29 on 2. So it's not going to be A, it's going to be E. One sec, let me just pause. You can sketch it, but the thing is, for starters, this one looks right, but the problem is that would give me a y-intercept of minus 8. And that, to me, doesn't look like minus 8.
It's like minus 8.
It looks like about minus 16-ish. So therefore, for me, the answer is C. It can't be this one because it's not a negative quadratic. This one would be an x-intercept of 2 and negative 4. That can't be that one. It doesn't have... It could have a turning point at 1 minus 20, but I don't believe... Yeah, it's definitely... But that wouldn't give me that. So, answer C? Yeah. Now, with these ones, which point does not lie on the graph? You could probably just do them in your head or do them in your calculator. So we're subbing each of those points in. When x equals 0...
How do you do that on the calculator?
Well, you just have to go 0 minus 2 squared plus 1 and evaluate it. And if that equals 5, which it does, then it lies on the graph. And then you would have to do over here 3 minus 2 in brackets squared plus 1. Yes, that equals 2. So there, and we just work our way down.
Oh, okay.
Nothing major. Yeah. I would not bother like sketching that graph, because then you'd have to trace the graph and it would just be a pain in the butt.
Doesn't that mean it lies on the line?
Yeah, it lies on the line. Which point does not lie on the line? So therefore we try 1 and 2. Now 1 minus 2 all squared plus 1 is equal to 2. 5 and 7. I reckon it's 5 and 7. That doesn't appear to be on the graph. So therefore, we just have to work our way and try those. If you want to sketch it, you can, but you're only wasting time. Okay, we're going to just continue here. What are the equations of the asymptote? I've already shown you how to sketch this on your CAS calculator, but remember, let's think about it more logically. What can x never equal? What can x never equal? 0. No, well, this x minus 1 can't equal 0. So therefore, x can't equal 1. So therefore, there's an asymptote at x equals 1, because we know that we can't, if we do 1 divided by 0, that can't be done. It's undefined. Now, if that whole fraction there on the left-hand side can't equal 0, therefore, that y can never equal y can never equal 1. Sorry, x can never equal 1, and y can never equal 3. So therefore the asymptotes are x equals 1, y equals 3. Otherwise, we could have sketched it in our CAS. If I sketch that in my CAS calculator and I go to this and I go get my fractions button up and I go 1 over x minus 1, make sure you go across. If you don't press the across button, it'll try to do it there. Plus 3. The CAS calculator does not show the asymptotes, but they are there. They are invisible dotted lines. But clearly, by looking at this, that we have a y asymptote at 3, because it never approaches that point, but it never gets to it. And we've also got an x asymptote at 1.
Wait. Because it
So by graphing it, you could see it as well.
could see it.
But you probably don't need to do that, especially since you have a bound.
Does that never actually touch 3?
Never touches y equals 3.
Okay.
Never touches x equals 1.
It looks like it.
Looks like it, but no. I'll keep going. Now, circular theorems. There's about 4 theorems that you guys need to have and committed to memory or in your bound reference. And remember though, you need to know them because in exam 1 you don't have a bound reference. One of those ones are that if I have a chord, that and in this example, it's not as obvious. This is my chord. Now, if I subtend an angle from one end of the chord to the other, that angle must be the same. So that angle y is the same. These two are the same angle. Now, the problem is, though, we don't really know what that angle is yet, but we have 98 degrees there, and we have a straight line. So that means that this angle here must be 82 degrees because they need to add up to 180. 92 and 82. 98 and 82. Now, 82 plus 56 is 138, and that is a triangle. So therefore, 138 plus 42 is equal to 180. My favourite number, 180. Yes? Yeah, okay, but remember I just said, Sebastian, that this angle here is the same as that angle there, which is one of your circular theorems. Okay, because they subtended from the same chord. So, alright, next one. This is a pretty straightforward one. If we have a quadrilateral in a circle which touches the diameter, which touches the perimeter, then those angles must add to 180. There you go. Answer is E. Answer is 75, which is E. Value of x. This is similarity. We know these triangles are similar because they share the same angle there. They both clearly have right angles. And these angles are also the same. Hence, they are similar. Now, I guess the easiest way to do this is that if they are similar, that means that 3 metres, the ratio of 3 metres to 0.5 metres would be equal to x metres over 5 metres. And I then am solving for x. In other words, though, what's the scale factor? The scale factor is 6. So in other words, if I got 5, then if I multiplied 5 by 6, then I would get 30. Or we can do it this way, where we've done it using the side lengths, and I'm solving for x.
We use x divided by what, sorry? 5.
Yeah, that's right, x divided by 5. So therefore, x would be equal to 5 times 3, which is 15. 15 divided by 0.5, which is equal to 30. Either way, you could have done it by finding the scale factor. The scale factor is 6. Multiplying 5 by 6 would give me 30. Okay, 5 times the scale factor would be equal to 5 times 6, which is equal to 30. So you could have done it either way. You could use ratio of side lengths or that. The next thing is, now it's on your formula sheet, question 19. What's the internal angles add up to in a polygon? How many sides do we have? We've got 1 side, 2 sides, 3 sides, 4 sides, 5 sides. Now, you know what? You might want to remember a formula, but you know what? What about this? This is a sort of a pretty neat way of doing it. How many triangles can I make out of this? 1, 2, 3. How many degrees in a triangle? 180. How many triangles do we have? 3. So what would all the angles add up to? 540. So we've got 540 degrees. Forget using the formula. That's only when you've got like 20 sides and 6 sides. Okay, maybe. But 5 sides, yeah, just do that. That's more fun. All right. So now what we've got is now we've worked out that there's 540 degrees. We can say that 90 plus 110 plus 3x plus 125 plus 95 is equal to 540. Yeah, there it is. So that's 220, 310, 420, 420. 3x must be equal to 120. So x is equal to 40. Is that right? Yeah. Good. Which congruence test proves that the given pair of triangles is congruent? Is it SAS?
Why is it on right hand side?
It's right-hand side. Right-hand side. Right-hand side, and actually we would have accepted both in that exam from memory. So right-hand side and SAS, same thing. We actually accepted both answers. Okay. Now remember that if we know if 2 side lengths are the same, then naturally if it's a right-angled triangle, that means its hypotenuse is the same. Okay. All right. How are we feeling so far with all of that? That's 27 minutes worth. All right. Just going to make